Hello. In this video entitled for 7th graders, we're going to consider the distance between 2 points. First on a number line and secondly in a plane. As far as finding the distance between 2 points on a number line, it's very simple. It is a subtraction. And if you begin with the bigger number minus the smaller number, you'll have the distance between the two numbers. Let's look at some examples. From first grade, a first grader will know that the distance between 5 and 2 is 3 units. You can count them starting at 2, but not counting the 2. Count the units between the 2 and the 5. 1, 2, 3. And 5 minus 2 is 3. What about if we have two negative numbers? Well, it works the same way. As long as the bigger number is first, the subtraction will provide the distance. So let's consider the distance between -5 and -2. Well, it is clearly 3 units, just like the distance between 2 and 5. But if we take the bigger number minus the smaller number, and in this case, of course, it is -2 minus -5. -2 is bigger than -5, so -2 and then the subtraction sign and then the -5. And of course, we have learned that to subtract a number, you add its opposite. So to subtract -5, you add +5. So this becomes equivalent to -2 plus 5, which is 3. The final case that we'd have to consider is, what if you have a positive number and a negative number? So let's say we want to know the distance between 2 and -5. Well, the distance between 2 and -5 is 7 units. You can count them out on the number line quite easily, 7 units. 2 is bigger than -5, so we do 2 minus -5. And once again, 2 minus -5 is equivalent to 2 plus 5, or 7 units. So to find the distance between two numbers on a number line, do the bigger number minus the smaller number. Now, what if you did the reverse? What if you did the smaller number minus the bigger number? You'd get the opposite of the distance. So in this case, if we had done -5 minus 2, that's -7, which is the opposite of the distance. So that's pretty much it for finding the distance between 2 points on a number line. That's not quite it. I'm sorry, I forgot about this. Before we move on to the two-dimensional plane, let's come up with a rule for, actually 2 rules for finding the distance between 2 points on a number line. Well, if B is greater than A, you can do B minus A. And if A is greater than B, you can do A minus B. As said a few seconds ago, the bigger number minus the smaller number will give you the distance. But could we come up with a rule that doesn't have these two parts? The answer is yes, because of the very useful concept of absolute value. You can say that the distance between any 2 points on the number line is the absolute value of A minus B, even if you don't know which of the two is bigger. Quick example. If A is 5 and B is 2, 5 is bigger than 2, so 5 minus 2 would give you 3. The absolute value of 3 is 3, so that gives you the distance. But what if the A were 2 and the B were 5? Well, 2 minus 5 gives you -3, but the absolute value of -3 is 3, so you'd have the distance. So you don't have to worry about which is bigger, which is smaller. You can simply say that the distance between any 2 points on the number line is the absolute value of A minus B. Now we will move on to the two-dimensional plane. First, we consider 2 special cases. In the x and y coordinate plane, let us find the distance between the 2 points 2, 3 and -4, 3. Well, the reason this is a special case is it's extremely easy because these 2 points are on the same horizontal line. And of course, the horizontal line that this line segment is a piece of Notice that each of the y's is 3. So the equation of the line that this horizontal line segment is on is y equals 3. So because it's a horizontal line, we can find the distance between the 2 points the same way we do on any line. We can simply take, ignoring the 3's, which are the same, we can take the x coordinates of 2 and -4 and subtract. Bigger minus smaller. 2 minus -4 is 6. And you can easily confirm that by counting. If this were a graph paper, you could count the boxes between these two using the grid lines, and you would go 1, 2, 3, 4, which would bring you here, and then 5, 6. So this horizontal line segment, looking at the two x coordinates, 2 minus -4 to get 6 units. The other special case is when the 2 points are on the same vertical line. Now, we notice this line segment here being part of a vertical line. Our eyes tell us that, plus the two x coordinates are the same. The two x coordinates are -2. So that means that this vertical line segment is part of the vertical line, x equals -2. Earlier we had a horizontal line. A horizontal line is always y equals a number. This is part of a vertical line. A vertical line is always x equals a number. That's an important concept from analytic geometry or the x and y coordinate plane. Well, we can ignore these two x coordinates and focus on the y coordinates. We have -1 and -5, and of course, if this were graph paper, you could simply use the grid lines to count, and the length of this line segment you would get 4, because you would count from here down or from down up and go 1, 2, 3, 4. Well, if we take the two y coordinates and take the bigger minus the smaller, we will get the distance, just like on any number line. The bigger y coordinate is -1. -1 minus -5, that's -1 plus 5, which is 4. So that would give you the length of that vertical line segment. Now we need to move on to the more general case where the 2 points are not on a horizontal line or not on a vertical line either. And the good old Pythagorean theorem will be the answer to the question there of what is the distance between the 2 points, as we will see. Now we are going to consider finding the length of the line segment between these 2 points, 2, 1 and 5, 4. We'll start fairly simple by keeping all of the coordinates positive. And the key to finding this distance is the Pythagorean theorem, and to realize that this line segment can be considered to be the hypotenuse of a right triangle. Well, what would the legs be? Well, if this were graph paper, you could trace over some blue grid lines to create the legs of the right triangle, and it would look like this. You'd have a horizontal leg and a vertical leg. On the graph paper, you would be tracing over some blue grid lines, and of course those grid lines are perpendicular. They form right angles, the vertical and the horizontal ones. So we have a right angle there. So we now have a right triangle, and we're trying to find the length of the hypotenuse. It's as simple as that. Now, again, the simple way to do this, if this were graph paper, you could use the grid lines to count, and you would determine, and you could even do it here on this board, starting here and going 1, 2, 3. This horizontal line segment is 3 units long, and so is the vertical one. Just kind of use the little points here on the y-axis as a guide, and you're starting here, you're going up 1, and then 2, and then 3. So each of these legs is 3 units long. What we have here is an isosceles right triangle. The 2 legs are the same length, so it's an isosceles right triangle. You already know, you should know, that the length of that hypotenuse is 3 times the square root of 2 units. We covered that in a previous video. This right triangle, because it's isosceles, can be considered half of a square. And this red line segment we're trying to find is the diagonal of a square. Recall that the diagonal of a square is always the square root of 2 times the length of one of the sides, because of the Pythagorean theorem. If we use our standard a squared plus b squared equals c squared, and the 3's are the a and the b, we'd get 3 squared plus 3 squared equals c squared. I'm going to bring the c squared over to the left, and 3 squared is 9, so we have 9 plus 9, or 18. And if c squared is 18, then c is the square root of 18. And that is the answer. That is how long. I'll put it in here on the red line segment we're trying to find the length of. It's the square root of 18 units. But, as you know, the square root of 18 can be simplified. It can be thought of as the square root of 9 times 2. And then we can break that apart as the square root of 9 times the square root of 2. The square root of 9 is 3, so we have 3 times the square root of 2. I'll write that up here as well. So that's it, except for the fact that there's a formula. The formula is nothing more than a working out of the Pythagorean theorem, as I'll show you. But I think before we look at the formula, we'll do one more example. Before we consider what is the distance between these 2 points, in other words, the length of that line segment with those 2 endpoints, let's make sure everybody understands the unit in this case. When we say that a line segment is so long in the x and y coordinate plane, what are we measuring with? Well, we're not measuring necessarily with inches or centimeters. We are measuring with the unit that is established by the x and y coordinate plane, by the grid lines. In other words, the distance between 0, 0 and 1, 0. That's the unit. Or the distance between these 2 points, -1, 0, and -2, 0. If this were graph paper, you'd have those blue squares. Well, the length of a side of one of those squares, that's the unit in the x and y coordinate plane. So make sure you understand that. On a standard piece of graph paper, that unit is usually 1/4 of an inch. Each side of each blue square is 1/4 of an inch, which is not a fun unit to use, measuring things in quarters of inches. I believe you can buy graph paper where each side of the square is 1 centimeter, which is a little bit more practical, but we don't have to worry about that. When we say that the distance is so many units, it's just that distance right there between this point and this next integer on the x-axis, or between this point and this point. That length right there is the unit. Okay, so consider this line segment to be the hypotenuse of a right triangle. And I'm going to just quickly sketch those legs of the right triangle. And on a piece of graph paper, I'd be going right over some blue grid lines. Okay, there it is. We're trying to find the length of the hypotenuse. Well, how long is each leg? You could count the grid squares. There'd be 2 here to get to the y-axis, you'd start here and go 1, 2, and then you're going to have 3 more on this side. This length is 5 units. Okay, 5 units. And then this vertical leg, again, counting with graph paper, it would be much easier. But up here, you've got 4. 1, 2, 3, 4. And down here, you've got 5 for a total of 9. So what we have is a right triangle with legs of 9 and 5. And we want to know the length of the hypotenuse. We want to know what C is. So C, of course, is going to be found through the Pythagorean formula, the Pythagorean theorem. C squared equals A squared plus B squared. Now, often we see the Pythagorean theorem described as A squared plus B squared equals C squared, but you can certainly say that C squared equals A squared plus B squared. That's actually a little bit more practical, as we'll see. So C squared equals, we'll call the 5A and the 9B. It doesn't matter which is which. C squared equals 5 squared plus 9 squared. C squared equals 25 plus 81. All right. C equals the square root of 25 plus 81. C squared is 106. So C is the square root of 106. I don't know whether that can be simplified. We won't bother doing that, but we certainly know that the length of C is a little bit more than 10 units. The square root of 100 is 10. The square root of 106 is irrational, but we know that it's a little bit more than 10. The calculator would tell us it's 10 point and then give us a real close approximation. So the answer here was, the answer we were looking for is that the length of this line segment, the red one, is the square root of 106 units. That's the distance between these 2 points. Here is the pretty famous distance formula. When we're considering points in the xy coordinate plane, we frequently will refer to 2 general points as x1, y1 and x2, y2 using subscripts. X1, y1 can be thought of as the x and y coordinates of point 1, and x2, y2 the x and y coordinates of point 2. The distance formula tells us that the distance between these 2 points will be the square root of x2 minus x1 squared plus y2 minus y1 squared. Now this looks very imposing, but it is quite simple. It is nothing more than the Pythagorean theorem. Remember, a moment ago, I said that it is frequently, it's nice to think of it as the Pythagorean theorem is C squared equals A squared plus B squared, and then you can immediately say what C is. C is the square root of A squared plus B squared. Compare this to what's up here. In fact, I put a little C in quotation marks next to the D because the distance between the 2 points is the hypotenuse of a right triangle. It's the C. The square root, this square root here has x2 minus x1 squared. Well, that's x2 minus x1 is the length of the horizontal leg. And this y2 minus 1, which is squared in the formula, that y2 minus 1 is the length of the vertical leg, with A being horizontal and B being vertical in this case. That's all it is. This is A squared plus the B squared. C equals the square root of A squared plus B squared. Let's just make sure that we see that that's true for the one that we just did. Well, we're calling this horizontal leg, which is 5 units long, we're calling it A. All right, that's the A. How long is it? Well, it's x2 minus x1. It's the x coordinate minus the other x coordinate. And if we do it big minus small, we'll get a positive number. But even if we do it the other way, small minus big, we're going to be squaring it anyway, so it doesn't matter that we get the opposite of the distance, because when we square it, it's going to be the square of the distance. It's going to be positive. What we have to do here is focus on we have to focus on the x coordinates. The x of this point is 3. The x of that point is -2. To find this length here, we do 3 minus -2. You see, because this horizontal leg here, which we know is 5 units long, this horizontal leg is on a horizontal line, which is y equals -5, right? Y, this is the line, y equals -5. So it's finding the length of this line segment here is just finding the length, the distance between 2 points on a horizontal line. So we'll go with the 3 minus the -2 to give us the 5. That's the x2 minus x1. x2 minus x1, 3 minus -2, giving you the 5. And in a similar way, this vertical leg is part of a vertical line. It's part of the vertical line x equals -2. Okay, so what we're going to do is we're going to focus on the y coordinates. And we're going to do big minus small. The y here is 4. The y of this point is -5. We're going to do 4 minus -5 to get the 9, which we already knew that it was. So that's the y2 minus y1. 4 minus -5 gives you the 9. It's really a lot easier than it might seem. It's kind of wordy for me to go through all this, but if you look through this video and you look through the Khan Academy video that I have referred you to, you'll see that it's a pretty simple matter to find the distance between any 2 points. Bye-bye for now.